All right, we're going to continue our discussions about ray diagrams, this time looking at converging lenses. I'm going to go really quickly through this. The assumption is you've done the ray diagrams, or at least familiarize yourself with how to do a ray diagram for mirrors. We're just going to tweak the rules a little bit, not totally throw them out, and you'll see that we can use the same three rays that we use for mirrors in order to predict the image from a converging lens. So much quicker this time than I've done it in the past, but here's how it looks. So first of all, as usual, we have our principal axis here. I'm going to give myself a object, and this time I'll be a little bit different here. I'll put my object somewhere between the center of curvature and the focal point. Now, what's different about a converging lens is we can actually identify on a converging lens the focal point, and they don't call it the center curvature, they call it twice the focal point, but we can identify it on either side of this lens. So I haven't taken a lot of care to make sure that these are measured carefully or equal or anything like that, but eyeballing it usually is enough to get you through. But if at first you want to do some measuring and make sure this focal point and this focal point are exactly on either side of the lens, go ahead and do that. I'm not going to. All right, so here's the three rays that we can draw. If that's my object, let me just label that so everyone knows in the end which one's the object, which one's the image. So we can draw three rays. Remember, the first ray is the ray that goes parallel to the principal axis and then refracts instead of reflects through the focal point. Now, because lenses have two focal points, it's really important to remember which focal point we're dealing with. And the way to, it takes practice, but in the end, the focal point for a converging lens is always a real one. So when we're done, we're going to make sure that these rays really go through this focal point. And there's not too many other ways to remember that. All right, so if that's our first ray, the one that goes parallel to the principal axis and then refracts, in this case, through the focal point, the second one could be the ray that goes through the, now in this case, it's going to go through this focal point. Again, it's a real focal point, so I want to make sure I draw my line through that focal point, and then that one refracts. And again, I'm not stressing that this doesn't actually hit the lens. I just kind of imagine where the lens would be extended here, and I draw it that way. So this is the second ray, the one that goes through the focal point in this case, and then when it refracts, it goes parallel to the principal axis. Let's highlight this one by making it blue. So there's the first one, there's the second one. I can already tell I'm going to have to make a little tweak to this first one. It's not long enough to show where they intersect, but I can start to see the intersection point here. Finally, the last ray. And this one, we had a ray for mirrors that went kind of through the center of curvature, or at least we put our ruler from the tip of the object and the center of curvature, and then it bounced straight off the mirror. This one, we can draw a ray that goes through what they refer to as the geometric center of the lens. So that is this point right through here. If I highlight it, the geometric center could be this point right around here, where, as much as it refracts in, the ray refracts, and in the end, it corrects itself, ends up looking like it just goes straight on through. Let's highlight this one by making it, let's make it, it's ugly orange. All right, so these are the three rays. And when we're done, we have a pretty good idea. Well, heck, we have a great idea of where our object will be produced. Our object looks like the tip of the object will be right here. And as usual, we just draw a vertical line. That might be my best one yet. That goes from where the tip is being produced, perfectly vertical, and hits the principal axis. So here's my image that's being produced over here. All right, so in summary, three rays. One that goes parallel to the principal axis, refracts through a real focal point. One that goes through a real focal point and refracts parallel to the principal axis. And one that goes straight through what we call the geometric center now of this lens. Think you can agree they're not totally different, but they are different enough that you got to pay attention from the ones that we did for curved mirrors. And with this image, if we were to summarize its characteristics, its attributes, it to me looks like it's larger than the original. It looks like it is inverted. And because the rays are really coming together, we will consider this a real image. Rays are really refracting and coming together here. So quicker than the other ones, but the assumption is the more you do, the better you get. So if you've done a few or practiced a couple even for curved mirrors, I would suggest do a bunch, but we'll talk about that later. If you've done those for curved mirrors, then this is nothing brand new. You just got to shift the rules ever so slightly.